Welcome to this section. We'll be learning about the biggest change to Vue. The latest major version of Vue introduced an API called the Composition API. Throughout most of this course, I've avoided talking about the Composition API. We haven't touched it once. The reason is because it has a larger learning curve. In my opinion, it's better to learn the basics of Vue before jumping into the Composition API. At this point, you should be more than comfortable with writing a Vue application. It's time to learn what this API is and why you would want to use it. So what is the Composition API? The Composition API is an alternative syntax for writing components. It's purely additive. You don't have to use it. You can continue creating components with the syntax you're already familiar with. The syntax we've been using is called the Options API. As you saw, it's completely possible to build fully functioning apps with the Options API. The Composition API was introduced for a couple of reasons, which we'll get into in a moment. The Composition API is not meant to replace the Options API. You can continue to write components with the Options API. If it were to be deprecated, I wouldn't have taught it to you. I don't want you to feel like you have to learn it. If you wish, you can continue to use the Options API without a problem. Here's a comparison between the Options API and the Composition API. Believe it or not, both examples do the exact same thing. They'll generate a component with a data property called bar. They'll have a method called greeting that returns a string. Despite performing the same task, they're written completely differently. The question then becomes, why should we learn the Composition API? Before I answer, I want to dispel some myths about the Composition API. You shouldn't learn it if you're hoping for better performance or security. The Composition API doesn't offer either of these. You'll get about the same loading times with either API. It wasn't introduced for these reasons. Under the hood, both APIs use the same functions for performing the same task. The Composition API isn't a replacement for the Options API. In fact, you can use both APIs in the same project. Let's get into why the Composition API was introduced. The first reason is that it offers better TypeScript support. Previous versions of Vue have had TypeScript support. Unfortunately, the implementation wasn't ideal. There were a lot of issues with it, mainly because of the Options API. It didn't allow for some of the design patterns you can create with TypeScript. The Composition API offers better support for TypeScript. You want to use the Composition API if you're going to use TypeScript. If you're not familiar with TypeScript, that's perfectly fine. The Composition API can be written in plain JavaScript. It isn't necessary to install TypeScript for writing components with the Composition API. The second reason is for better organization. The Options API works well for small to medium-sized components. Sometimes you'll create large components where organization may become an issue. A component may have multiple features. Here's an example of a component with two features. We have a property called user and a method for retrieving the user called getUser. There's another property called cart and a method for retrieving a product called getProduct. It's easy to see that the user property and getUser method work hand in hand. The same can be said for the cart property and getProduct method. As you can see, visually, the logic is separated. It doesn't seem like a big issue, but it is when you're working on larger components. You will have to constantly scroll up and down to work on a single feature. Here's the same example, but written with the Composition API. By using the Composition API, you can organize code more freely. You're not bound to defining logic in specific objects. There's more liberty as to where you can define things. I'll bring back the visual. If we compare the two, the Composition API allows for better organization. It helps keep you focused on the feature you're working on. Here's a more extreme example. This example was taken from the Composition API documentation. To the left, we have the component written with the Options API. It's highly disorganized. To the right, we have the Composition API. It's much more cleaner and organized. This freedom is one reason why you would want to use the Composition API over the Options API. The last reason is that it offers better reusability. This is probably the biggest reason to use the Composition API. Chances are you'll want to reuse some of the logic you've written. In previous versions of Vue, the only way you can reuse code was by using a feature called mixins. Mixins weren't that great. They didn't have great IntelliSense support. This meant you had to go back and forth between files to understand what was exposed to you. There were also problems with conflicting names between mixins and components. Lastly, there weren't better alternatives to mixins. We'll be learning about mixins in the next lecture. Don't worry if you're not familiar with mixins. The Composition API fixes these issues. You'll better understand why this is important in the next lecture. That about sums up why you would want to use the Composition API. It has TypeScript support, easier to organize code, and better reusability patterns. In the next couple of lectures, we'll learn about the Composition API. In this lecture, we're going to learn about mixins. They're a way to reuse logic within components. Reusability can make your code more readable and manageable. Vue offers a solution called mixins to help you with reusability. Let's explore how to use mixins. In the resource section of this lecture, I provide a link to the mixins documentation page. Here is what Vue says about them. Mixins are a flexible way to distribute reusable functionalities for Vue components. A mixin object can contain any component options. When a component uses a mixin, all options in the mixin will be mixed into the component's own options. If you have properties similar to one another from component to component, you can use a mixin to prevent yourself from rewriting the same code. It's common to have functions that you want to share amongst many components. Mixins are the perfect solution for this. For this example, we're going to create a mixin that will keep track of the page's scroll offset. We'll add the mixin to a component. In the resource section of this lecture, I provide a zip file with the starter files you'll need. Upload it anywhere you'd like. After uploading it, run the npm install command. Lastly, start the server with the dev command. There's nothing much to say about the starter files. Pretty much all of them are the starter files you'll receive if you select the default preset. I've made changes to the app component file. Open it in your editor. In the template, we have two elements called app and scroll position. The app element acts as a container. If we scroll down to the CSS, we'll see that it has relative positioning. We're giving it an abnormally large height. We're using a large height because we want to be able to scroll up and down the page to view the results. The scroll position element has a fixed position. We want to be able to see it whenever we scroll. We want to see it because it'll contain an expression that'll output the scroll offset. You'll see what it looks like in a moment. First, we need to create the scroll properties. We'll be creating it in a mixin. In the source directory, create a file called mixin.js. Inside the file, we'll export an object. Mixins don't work on their own. They're not meant to. They are objects that will merge with an instance of Vue or a component. The options we create in a mixin must match the option names in a component's options object. If we want to create data, then we'll need to create a data function, so on and so forth. We're going to create a data property for storing the scroll offset. Define the data function inside the mixin. Add a property called offset. Set its initial value to 0. The offset will be 0 because that's the initial value the browser will assign the offset to. We want to be able to update the offset whenever the user scrolls on the page. The browser emits an event we can listen to for when this occurs. We'll start listening for the event when the component is mounted. Define the mounted lifecycle function. Inside the function, we'll listen to the event by calling the window.addEventListener function. The name of the event is called scroll. If the event is emitted, we'll call the this.update function. This function isn't defined. Let's define it next. Add the methods object to the mixin. Define the update function. Lastly, we'll set the offset data property to the window.pagey_offset property. We have a mixin for keeping track of the offset of the page. We'll want to merge this mixin with the app component. This can be done by registering a mixin. We can register a mixin locally or globally. Let's start with a local mixin. Back in the app component file, we'll import the mixin file. To register the object as a mixin, we need to add the mixin's property to the component's configuration object. The mixin's property needs to be set to an array. The array should be the objects that you would like merged with the component. In our case, we want to merge the scroll mixin object. We'll pass that in. The properties and methods from the mixin will be accessible via the this keyword. We can treat them as if they were the component's options to begin with. We'll want to display the offset in the template. We have a div tag with the class scroll position. It's empty. Let's add an expression inside it. The expression will be set to offset. Let's check out the application in the browser. If I scroll up and down, the expression will be updated with the scroll offset. Even though the code wasn't written in the component, Vue merged the mixin with the component's options. Mixins allow us to reuse code by outsourcing the logic into a separate object. We can add this mixin to any component. There are a couple of things to be aware of when using mixins. Firstly, an instance or component's options will always have priority. Let's look at an example by switching back to the editor. Let's create a data function in the app component file. Inside the object, we'll add a property called offset. Its value will be 0. The mixin already has an offset data property. Vue will use the property in the component. The mixin's version of the property will not be merged with the component. This doesn't mean the other methods we have in the mixin will not get included. The update method will get merged with the component because the component doesn't have it defined. Another thing worth noting is that components don't share mixin data. For instance, if I were to register the mixin with another component, it won't share the offset data property with the app component. They'll be treated as independent properties in their respective components. We don't have to worry about things leaking from one component to the next. One component does not influence any other component's data even if they're registering the same mixin. The mixin's properties are duplicated. All components will have a unique version of the data. One last thing worth noting is how lifecycle functions are treated. If a mixin and component have the same lifecycle function defined, they'll both run. Let's look at an example. Inside the app component file, we're going to add the mounted lifecycle function. We'll log a message that says the following: app mounted lifecycle function. The mixin is already defining the mounted lifecycle function. When it comes to lifecycle functions, Vue will push both methods into an array where both functions are called. Let's view the browser to see what happens. If I scroll up and down the page, the offset will continue to get updated. This can only happen if the mounted function from the mixin was called. Let's open the console to see if the message is logged. We'll find that the component's mounted lifecycle function was called. If a component defines a lifecycle function, it'll get called along with the mixin's lifecycle function. This gives us the opportunity to define lifecycle functions without them conflicting with another freely. Mixins can be useful for generating generic functions that can be shared across multiple components. While mixins are great, there are a few issues with them. Let's discuss what those issues are to discover why the development team behind Vue decided to create the Composition API. The biggest problem with the Mixin API is namespace clashing. We have an example in our project. The offset data property in the component clashes with the mixin. We don't get an error from Vue or the editor about the problem. Vue will make an assumption. It'll assume the data property in the component should be used. But what if we wanted to use the offset in the mixin? Well, that's not possible unless we change the names. If we want to prevent clashing from happening, we'll have to look inside the mixin file to discover what property names are taken. The mixin doesn't directly tell us what gets added. We have to peek inside the mixin file to discover what gets added to the component. This problem can be amplified if you have multiple mixins registered to a component. Not only will you have to check if a component has any clashing names, but you'll also need to check with the other mixins. Vue will not tell you if there are namespace collisions. Mixins can easily override one another. It's for this reason that mixins are problematic. It's challenging to develop a system that will tell you when you have namespace clashing with mixins. You can avoid this issue by opening the files and checking the names manually, but it's something that can be easily overlooked during development. The Composition API is much better at handling this issue. With that said, let's learn about the Composition API. We'll look at how this issue is resolved in the next set of lectures. In this lecture, we're going to get started with the Composition API. Before you start, I recommend downloading the starter files in this lecture. Upload it anywhere on your machine. After uploading it, run the npm install command. After installing the packages, you can start the server. Pause this video if you need to set this up. The files in this project are the default files in the default preset. I've made changes to the app component file. It's been stripped down to an empty object and a basic template. We'll be keeping things reasonably minimal to focus on the Composition API. The very first thing we'll need to do is add the setup function to the options object. This function is where we must create our options with the Composition API. This is the first difference between the Options API and Composition API. Previously, we had to create our options in specific properties. The Composition takes a different approach by allowing you to add options inside this function. This approach gives you more freedom because you can arrange your options in any order you'd like. The first thing we'll create is some data. Inside this function, define a variable called number. Its value will be 0. We want this variable to be accessible in the template. The setup function must return an object of properties and methods we wish to expose to the components template. We'll return an object with the number variable. The number variable will be exposed to the template. We'll modify the template to output the number variable. Inside the div tags, replace the content with a pair of paragraph tags. We'll add an expression for the number variable. Let's reload the page in the browser. The number gets rendered onto the document. Creating variables in the setup function is the equivalent of defining data properties in the Options API. If we want the data to be available in the template, we'll need to return it from the setup function. Vue will check if you have the setup function defined in a component. If it is, it'll be called when the component is created. The number by itself isn't that interesting. Let's make the application more interactive by adding a button that will increment the number. Let's move back to the editor. Inside the setup function, we'll define a function called increment. Inside the function, we'll increment the number variable with the increment operator. We want the function to be exposed to the template because we want to call it when a button is pressed. We can do the same thing we did last time. We can add it to the object returned by the function. This is the equivalent of defining a function in the methods object with the Options API. The method will be exposed to the template. We can call it like we would any other method. In the template, we'll add a button below the expression. On the button, we'll add the click event listener with the prevent modifier. If the click event is emitted, we'll call the increment function. Time to give things a test. Back in the browser, try to click the button. Nothing happens. The template does not reflect the variable's value. Why is this the case? If we look at the console for more information, nothing happens here either. Vue will not update the template because the variable is not reactive. We learned about reactivity in the second section of this course. Let me recap what reactivity is. Reactivity is the process of updating the template whenever a change occurs in the data. The properties in the data object are reactive. Vue will take the time to make your data reactive when the component was initialized. You didn't have to perform this part of the process yourself. Things are different with the composition API. We're the ones responsible for telling Vue which variables in the setup function should be reactive. This is what's called reactive reference. A reactive reference is a variable that Vue will keep track of. Any changes to the variable will be reflected in the template. It adds reactivity to the variable. We can create a reactive reference by using a function called ref. At the top of the script block, we're going to import the ref function from Vue. The ref function will wrap a value with reactivity. Back in the setup function, we'll wrap the value for the number variable with the ref function. We'll need to make one modification to the increment function. Instead of accessing the number variable directly, we'll access a property called value. The ref function returns an object. If we want to make changes to the value, we'll need to access it via the value property. This is only for when we want to make changes to it. When we return the reactive reference, we need to return the entire variable. In the template, we don't have to update the expression. Behind the scenes, Vue will detect that the number variable is a reactive reference. When it finds a reactive reference, it'll automatically expose the inner value. We don't need to access the reference's value via the value property. The template can remain unchanged. One last thing before we test this. We're going to log the number variable to check out what the ref function returns. Alright, let's give things a test. In the browser, try clicking on the button again. The expression in the template gets updated. This is great. It's exactly what we were looking for. Open the console to view the object returned by the ref function. The object comes with a getter and setter. This is how Vue can update the value and retrieve it. It's important we use the ref function if we want our variables to be reactive. It'll wrap the value with functions necessary for making it reactive. Back in the editor, I'm going to remove the log statement from the function. We've successfully created some data for our component. We'll look at what else we can do with the composition API in the next lecture. In this lecture, we're going to look at another function for creative reactive references. Vue provides us with two functions for creating reactive references. The first function is the ref function. The second function is called reactive. We'll learn about the reactive function next. Afterward, we'll discuss the differences between the two functions. In the setup function, we're going to create a variable called user. It'll be set to an object. One thing I want you to notice is that we're defining the variable below the increment function. We can place the variable definition anywhere we want in the setup function. This flexibility is one of the main benefits of the composition API. We can arrange the code inside the function by logic. The number variable and increment function are grouped together. We don't have to scroll around to work with it. Moving on, we'll create two properties in the user object called name and age. Assign the properties any values you'd like. Just like the number variable, this will not be reactive. If we were to add the variable to the list of values to return, it'd be available in the template during the mounting phase. However, it will not be reactive. We can make it reactive with the reactive function. At the top of the script block, we'll add onto the list of functions to import by adding the reactive function. This idea of importing function is a common thing we'll have to perform whenever we want to add functionality to our component. The Composition API requires we import the functions we want. They do not automatically get injected into the component. We'll wrap the user object with the reactive function. Next, we'll return the user object. We'll want to test its reactivity. Below the variable definition, we'll create a timeout with the setTimeout function. It'll run after 3 seconds has passed. Inside the callback function, we'll update the user.name property to a different value. This is one difference between the reactive and ref functions. The value returned by the reactive function is an object with reactivity. The properties don't need to be accessed via a value property. You can access them like you regularly would. The last thing we'll do is use the object in the template. Scroll to the template block. We'll add a paragraph tag below the button. We'll insert an expression inside the tag. The expression will be set to user.name. Let's refresh the page. After 3 seconds, the name will change because we updated it in a timeout function. The reactive function is another way to make a variable have reactivity. It doesn't seem that much different than the ref function. So what are the differences between the two? The biggest difference is the types of values you can use in either one. The ref function is meant for primitive values, such as strings, numbers, and booleans. If you want to create a reactive object, you'll need to use the reactive function. You can't pass a primitive value to the reactive function. Otherwise, you will receive errors for doing so. Both functions add reactivity to your values, but for different data types. The other difference between the two functions is how values are accessed. The ref function returns an object where the original value is stored in a property called value. If you're using a reactive reference in a template, you don't have to access it through the value property. Vue will take care of unwrapping the object for you. The value can be accessed directly through the variable. The reactive function doesn't move your values. They will remain in the exact location you defined them. This applies to when you're using them in the setup function and in the template. This brings us to the next question. When should we use either one? Theoretically, you can use the reactive function once to store all the component's data. However, this is not recommended for 2 reasons. Firstly, you miss out on the organization the Composition API offers. It defeats the purpose of using it. Secondly, there are limitations to the reactive function. We can't destructure the object, nor can we use the spread operator. This limitation is something you may want to do to make your code more readable. Let me show you what I mean. In the return statement, we're going to add the spread operator to the user variable. We'll update the expression we used in the template for the user object. We'll update the expression from user.name to name. Let's refresh the page on the browser. After 3 seconds have passed, the name will remain the same. This is because we lose reactivity if we were to attempt to spread the object. However, it is possible to have the best of both worlds. Vue introduces a function for converting a reactive object's properties into individual reactive references. Let's go back to the editor for a moment. We're going to update the import statement for the Vue package by adding a function called toRefs. The toRefs function converts an object's properties into separate reactive references. In the return statement, we can wrap the user variable with the toRefs function before spreading it. This function will allow us to keep the object, but shorten the names in the template. Let's refresh the page to check if the name updates after 3 seconds. The name becomes reactive again. The toRefs function assists you with spreading an object while also allowing you to keep the properties reactive. Despite its availability, I don't recommend using it for storing the entire component's data in a single object. Data in objects should be grouped by how relative they are to one another. In the resource section of this lecture, I provide a link to the topic of refs versus reactive. I recommend reading this after you've become more familiar with the Composition API. It gives a bit more information about the differences between the two functions. In this lecture, we're going to learn how to create watchers and computed properties with the Composition API. The concepts we learned with the previous API will remain the same. Watchers and computed properties function the same in the Composition API as they did in the Options API. The syntax is just different. We'll start by learning how to write watchers. Watchers are a way to watch properties on components. If a property changes, we can run a function to execute further logic. The watcher will reverse a string if an input field is changed. Vue has two functions for creating watchers. Let's explore them both. We'll continue working in the app component file. In the setup function, we'll create two variables called phrase and reversed phrase. Both will be set to the ref function with an empty string. Next, we'll add them to the return statement. We'll be able to use them in the template. Below the other paragraph tags, we'll add another one with an input. We can bind the input to the data by using the vModel directive. Its expression will be the phrase reference we created. Below this, we'll want to output the reversed phrase as well. We'll create a pair of paragraph tags with the expression. This won't work yet because the reversed phrase variable will never be updated. We want it to store a copy of the phrase variable but in reverse. This issue can be resolved by using a watcher. In the script block, we'll update the import statement for a function called watchEffect. The watch function allows us to watch dependencies in the component. We'll want to use it to update the reversed phrase variable if the phrase variable changes. Down in the setup function, we'll call the watch function. The watch function can be used in various ways. We'll start by learning the most straightforward way of using it, which is to pass in a function. In the function, we'll set the reversed phrase.value property to the following: phrase.value.split.reverse.join. This chain of function will reverse the string. Vue will look at the contents of the function. It'll notice we're using the phrase variable as a dependency. It'll start watching the phrase variable for us. If it ever changes, it'll run the function we passed in. This will cause the reversed phrase variable to update whenever the user inputs a string. Let's try testing this out in the browser. Anytime we fill in the input, the variable is reversed. This approach is one way of using watchers. Let's explore the second function for creating watchers. We can make the watcher more efficient by telling it what it should watch instead of letting it guess what to watch. Back in the editor, let's update the import statement to include a function called watch. Next, let's replace the watchEffect function with the watch function. The first argument will be different from before. Instead of passing in a function, pass in the phrase variable. This argument will tell the watch function to only watch the phrase variable. If the contents of the function has other dependencies, they will not trigger the function to run. If we decide to tell the watch function what dependencies to watch, we're passed in two arguments to the callback function. They're the new and old values of the dependency we're watching. In some scenarios, we'll want to watch multiple dependencies. We can watch for multiple dependencies by changing the first argument of the watch function to an array. The array will contain a list of dependencies to watch. We'll wrap the phrase variable with square brackets. If we decide to watch multiple dependencies, the parameters for the callback function will be arrays as well. We'll wrap the parameters with square brackets like so. This form is probably the best way to use the watch function if you want to be specific on what you want to watch. The watcher we created is very simple. Therefore, I'll comment out the function and recall the watch effect function with the original solution. This is how we can create watchers. The concept remains the same. All that's changed is the syntax. Let's move on to learning about computed properties. Computed properties function the same in the Composition API as it did in the Options API. They are properties that'll store a cached value. If the dependencies inside the function get updated, the function will be called again. The property will be updated with the value returned by the function. They're similar to watchers, but the function for computed properties must return a value. Let's start writing a computed property. The computed property will double the number in the component. Computed properties can be created by using the computed function. We'll need to import it if we want to use it. At the top of the script block, we'll update the import statement for the view package to include the computed function. Then, below the increment function, we'll create a variable called double. It'll be set to the computed function. The computed function expects a function to be passed in. We'll pass in an arrow function. The function must return a value. We'll return the num.value property multiplied by 2. The computed and watch functions are similar to one another. They'll watch the dependencies in the function you passed in. One big difference between the two is the computed function will return a reactive reference. We'll be able to use the reference in the template if we decide to add it to the return statement. In fact, let's do that. Something to keep in mind, since the computed function returns a reactive reference, the value of the computed property is hidden inside the value property. If we're returning the computed property, View will do what it does for other reactive references. It'll unwrap the reference to allow you to access the value directly through the name. Inside the template, we'll add a paragraph tag below the num expression. Inside it, we'll have an expression that outputs the double computed property. Let's switch to the browser to view the result. Every time we press the increment function, the double computed property will be double the number. The computed function will notice we're using the num variable. It'll keep track of it to know when to run the function we passed in the computed function. We're finished with learning about watchers and computed properties. They allow us to watch the dependencies and variables in a component. The main difference between the two is the computed function will return a reactive reference, whereas the watch function will not. In this lecture, we're going to learn how to use the lifecycle functions in the Composition API. The process of using a lifecycle function is not much different than what we've been doing so far. We import a function and then we can call it. We can use most of the lifecycle functions in the Composition API. Regardless of what lifecycle function you decide to use, all of them start with the word on. Here are some examples of some of the lifecycle functions available. Two functions have been renamed. The beforeDestroy hook has been renamed to beforeUnmount, and the destroyed hook has been renamed to unmounted. The name changes have been made to more accurately describe what happens to a component when it's removed from the document. There are additional lifecycle functions such as the activated and deactivated hooks. These are called if you're wrapping your components with the keep alive component. It's not common to use these, but they are available. One last thing worth noting. The composition API doesn't support the beforeCreated and created lifecycle functions. This is because the setup function runs after the beforeCreated hook, but before the created hook. Rather than supporting both hooks, Vue recommends you write your code inside the setup function that would generally be in these hooks. Let's use some of the lifecycle functions in the composition API. We'll be working on the app component file for this example. At the top of the script block, we'll import two functions called onBeforeMount and onMounted from the Vue package. We must import the functions if we want to hook into them from the component. As a reminder, every lifecycle hook is prefixed with the word on. We'll use both functions in the setup function. Add them at the very top. We can run code during the lifecycle by passing in a callback function. Let's pass both hooks an arrow function. We won't do anything crazy in the lifecycle hooks. For demonstration purposes, we'll log a message to let us know which function gets called. Let's run the application in the browser. Open the console in the developer tools. We'll see both messages logged in the console. This result proves we were able to use the lifecycle functions successfully. Lifecycle functions are very easy to use in the composition API. You need to import them, call them in the setup function, and provide a callback function. The callback function is called during the lifecycle. There's not much else to it. In this lecture, we're going to learn how to use props in the composition API. Props haven't changed that much in the composition API. The composition API doesn't replace everything. There are still some options we can define in the component. Here's what we'll do. We'll create a component that will output an alert message if the name of the user changes. We created a timeout function that will change the name of the user. It would be nice if we can get alerted of when the change occurs from the parent component. In the components directory, create a file called alert.vue. We'll scaffold the template and script blocks. In the template block, we'll add an empty div tag to prevent Vue from throwing an error during compilation. Great! We can import the component into the app component. Back in the app component file, import the alert component. We can register the component by using the components option. We'll add it to the component with the alert component passed in. The composition API doesn't completely replace the options API. There are still some options we can use for things like registering the component. The composition API provides functions for creating data, methods, computed properties, watchers, and lifecycle functions. Everything else is still performed with the options API. We'll load the component in the template. We'll place it below the other elements. The alert message the component will output will be based on if the user's name changes. We'll need to provide it with the user object. We'll bind a property onto the component called user. Its value will be the user object. This binding will throw an error because the setup function is not returning the user variable. It won't be accessible in the template. We'll update the return statement to include the user variable. Time to work on the alert component now that we have everything we need from the parent component. Back in the alert component file, we're going to accept the user object by adding the props option to the component. The props option is another option that isn't available in the composition API. We still need to use the options API if we want to accept properties. The next thing we'll do is use the user prop to create a computed property. It'll check if the user prop has changed. Since we'll be creating a computed property, we'll import the computed function from the view package. Next, we'll add the setup function to the component. Afterward, we'll define a variable called flag. Its value will be the computed function with an arrow function passed in. Inside the function, we'll want to use the prop. However, here's the problem. The setup function runs before the component's props, data, methods, and computed properties are registered. It runs before any of the lifecycle functions. We don't have access to anything. The this keyword won't work in the setup function. This is a problem because we want to be able to use the props passed down from the parent component. Luckily, the setup has an optional parameter called props. We'll add the props parameter to the function. This parameter will give us access to the props passed down from parent components. In addition, the second parameter to the setup function is called context. This parameter will give us access to the other properties and methods in the component. You can think of it as the equivalent to the this keyword. We won't be using it for this example, so we won't add it to the function. In the callback function for the computed property, we'll return the following: props.user.name == John. This value is the default value for the name property in the object. If this turns out to be false, we'll want to output a message. We'll handle this in a moment. Before we do, we'll need to return the flag variable for it to be exposed to the template. The last thing we'll need to do is add the message. On the div tag, we'll add the vIf directive. The condition will check if the flag variable is false. If it is, we'll display the contents of the element. Inside the element, we'll add some text to let the user know the name has changed. To make it more noticeable, we'll change the color of the text to red by using the style attribute. Let's try running things. In the browser, refresh the page. After 3 seconds, the name will change because we have the timeout function running. The message will appear because the parent component sends the updated value to the alert component. This will cause the function in the computed property to run. The main takeaway from this lecture is how we're using props in the child component. It's slightly different because we don't have access to props through the this keyword. We have to use the props parameter in the setup function to be able to use props. It's a different approach that you'll need to be aware of. In this lecture, we're going to learn how to use template refs with the Composition API. Template refs, as we've learned, are a way to interact with the elements in a component. They expose the native browser API for interacting with elements. It's a feature available in case any other solution is not viable. Working with template references is a slightly different process than before. Let's look at how it's done. In the template, let's add a button at the bottom of the template. We're going to add an event listener to this button. However, for this demonstration, we're not going to use Vue's binding syntax for listening events on elements. We'll use template references. The syntax for using template references in the template hasn't changed. We can add the ref attribute to the button element. The name for the reference will be button. The next step is to add an event listener. However, there is a problem. In our setup function, we don't have access to the this keyword. It's because the setup function is called before the component is instantiated. Template references are accessible via the $refs variable. If we want to access template references, we need to create a variable that'll store the reference. This might be confusing, but just follow along. I'll explain what's going on in a moment. At the top of the setup function, we'll create a variable called button. Its value will be the ref function with a value of null. The ref function isn't limited to storing primitive values. It's able to store template references too. If we plan on using a reactive reference to store a template reference, its initial value must be null. Next, in the return statement, we can add this reference to the list of values to return. When the setup function is called, Vue will create the reactive reference. It won't be bound to anything until the component has been mounted. During the mounting phase, Vue will notice we have an element with the ref attribute. The value for the ref attribute must correspond to the name of the reactive reference we have in our setup function. Vue will assign the element to the reference. We'll be able to interact with the element in our setup function after the component has been mounted. We can proceed to add an event listener. In our setup function, it's important we add the event listener after the component has been mounted. If we were to attempt to add the event listener, we'll receive an error because the button variable will be null. Luckily, we talked about lifecycle functions already. We already have the onMounted lifecycle function in our function. We can update the callback function by calling the addEventListener function on the button.value property. Keep in mind, we're still using a reactive reference. If we want to access the value, which in this case is the element, we'll need to access it via the value property. That's where Vue will store the element. The name of the event we'll listen to will be the click event. Next, in the callback function, we'll log a message to let us know if the button was clicked. Let's test the button in the browser. If I press the button, the message gets logged from the event listener's callback function. Great! We've learned how to use template references with the Composition API. It might seem a little confusing because there are two types of references we're working with. To add clarity, let's talk about the differences. In the template, we added the ref attribute to create a template reference. A template reference is an object that allows us to interact with the HTML element in the document. In our setup function, when we call the ref function, we're creating a reactive reference. A reactive reference is an object that's being observed for changes. We mainly use reactive references for storing primitive values, but it can be used to store a template reference. That does it for now. I'll see you in the next one. In this lecture, we're going to learn how to emit events from the setup function. Previously, we had to look at an alternative for accessing refs in the script section of the component. Vue likes to inject global methods and properties via the this keyword. Since we're working with the Composition API, those global functions are gone. In some cases, we may need to emit custom events. Events can be emitted from components by calling the this.$emit function. We don't have access to this function from the this keyword. If we want to emit events, we'll need to update the parameters of the setup function. Currently, I'm in the alert component. We're accessing the props via the props parameters. The second parameter of the setup function, if we choose to use it, is the context object. The context object gives us access to information about the component it's being used in. This object comes with the emit function we would regularly encounter in the this object. If we want to emit an event, we can call the context.emit function. The emit function has the same arguments as the this.$emit function. The first argument is the name of the event. This can be a custom named event. The second argument is a payload to send to event listeners if there are any. We aren't going to emit any events from this component. I just wanted to show you can emit events if you ever need to. I'm going to remove this line as well as remove the context parameter from the function. After making those changes, I'll see you in the next lecture. In this lecture, we're going to learn about the advantages of the Composition API. We've become familiar with the API in these past few lectures. You have all the knowledge you need to start using it. I want to discuss one of the main advantages of using the Composition API. We'll see how it matches up against mixins. In the very first lecture, I briefly went over the reasons why you'd want to use the Composition API. Firstly, it has better TypeScript support. If you're not familiar with TypeScript, that's perfectly fine. As you saw in the past few lectures, it isn't necessary to use TypeScript with the Composition API. Secondly, it allows for better organization. We saw firsthand how that works. We were able to define variables and functions in any order we'd like. Unlike the Options API, we weren't bound to defining everything in specific locations. If we want, we can move everything to random places in the setup function. The component will still work. Thirdly, it makes reusability easier. It opens up an interesting pattern for reusing code that's better than using mixins. In this lecture, we're going to specifically look at how we can create reusable code. Before we dive into some code, there's a concept I want to discuss called a composition function. The definition of the word composition is the action of putting things together. In that regard, a composition function is a function made up of other functions. It's common practice to want to combine things together for reusability reasons. If you have common logic among components, you will most likely outsource the code in a separate file, import it, and then load it into the component. Currently, I'm working on the mixins project we worked on in Lecture 2 of this section. Towards the end of the lecture, I showed you one of the biggest problems with mixins. In the data object, we have a property called offset. If we were to look at the mixin file, we'd see that it also has a data property called offset. Despite that, switching back to the component, we aren't receiving errors. We won't get errors in the browser nor in the editor. We aren't aware of the problem this will cause because the environment we're working in won't throw an error. This will mean we'll have to investigate by looking around our code and files to find the issue. For something small like this, it won't take long to find the culprit of the issue. However, in larger projects, this can quickly become a nightmare. We can't even rename the properties in the component if we found a conflicting name. We would have to open the mixin file and rename the property from there. Then, we would have to go to every component that uses the mixin to reflect the change. It's not an efficient way to go about things. There are workaround patterns available such as high-order components. The Vue team has decided to provide a solution that's much easier to work with. The Composition API is the solution they came up with. Let's go back to the Composition API project we were working on. The setup function has become quite large. It's starting to become unreadable. Let's split the function into multiple functions. There are two things we'll put into separate functions: the code for the number example and phrases example. We'll create a directory for holding our code. In the source directory, create a folder called hooks. The name hooks is a common naming convention for composition function files. Inside the newly created directory, create a file called number.js. We're going to export a function called useNumber. Next, back in the app component, we'll cut the num variable, increment function, and double computed property. We'll paste this into the number function we exported in the number.js file. The ref and computed functions will need to be imported from the Vue package. We'll do that at the top. We'll return the num, increment, and double values in an object. We've successfully created our first composition function. Just like mixins, by themselves, composition functions aren't meant to be used alone. They're meant to be merged with a component. We gave our composition function a unique name by adding the word use before the name. It's not required to do this. It's common practice to prefix functions with the word use. It helps developers identify if the function is a composition function. It's a function meant to be merged with a component. The naming convention is inspired by React. If you've worked with React, you're probably familiar with this naming convention. It's a great way to help developers to identify composition functions. We'll be following this practice. Let's merge it with the component. Back in the app component file, we'll import the useNumber function from the number file. Then, right before the return statement, we'll create a variable that destructures the object returned by the userNumber function. In relation to reusability, here's one advantage the Composition API has over Mixins. We don't have to retrieve every property and method from the composition function. We have the option of selecting what we want to grab from the function. When we're working with Mixins, Vue will merge the entire Mixin object with the component. We don't have a say in the matter. By using the Composition API, we'll have an idea of what we can retrieve because of IntelliSense. IntelliSense is a feature in Visual Studio Code. You may have an editor that has something similar. It's the ability to perform code completion. The editor is able to detect what the function is returning. It'll output a list of possible values. This feature helps us greatly because we won't have to switch back to the file to check what's being returned. This feature isn't available with Mixins. We're going to grab the num, increment, and composition properties. We won't need to update the return statement because the values are using the same names. We're finished with creating our first composition function. Let's work on creating another. We have two variables for containing the phrase. We'll move these into a composition function. The watcher will be moved too. Create a file called phrase.js inside the hooks directory. We'll return a function called usePhrase. Switch back to the app component file. We'll cut the phrase variable, reversed phrase variable, and watch function. Paste them into the usePhrase function. We'll add a return statement to return the phrase and reversed phrase variables in an object. At the top of the file, we'll import the ref and watch function from the Vue package. The composition function is ready. Back in the component, we'll import the usePhrase function from the phrase file. While we're here, we can update the import statement from the Vue package to remove the computed and watch functions. We don't need them anymore. Back down in the setup function, we'll create a variable that destructures the object returned by the usePhrase function. We'll want to grab the phrase and reversed phrase properties. We don't need to update the return statement in the setup function because the names are the same. Let's give things a test. In the browser, refresh the page. If we press the increment button, the numbers will continue to work. The form for inputting a phrase works too. We'll even get the phrase reversed. Fantastic! We've created two composition functions. They're highly reusable. We can use them in any component without experiencing the same issues we had before. We can even rename the variables. This flexibility isn't something we were able to do with Mixins. Let me show you what I mean. Back in the editor, we're going to modify the phrase file. We'll create another reactive reference. It'll be called num. Its value will be an empty string. We'll add it to the return statement. Back in the component file, we'll add it to the list of properties to extract from the object. Our editor will throw an error. It's saying that we already have an identifier called num. The number composition function is already returning a variable with the same name. We have two identifiers with the same name. Previously, Vue would use whatever mixin it wanted if there were conflicting names. It didn't throw an error at us. Things are different with the Composition API. At the end of the day, we're writing JavaScript functions. This will not slide with JavaScript. It does not like it when there are conflicting names. Luckily, we can resolve this issue by renaming the variables in the component. We don't have to rename them in the composition functions we created. JavaScript allows us to rename properties we destructure. We'll assign the num property the name of phrase num. Next, we'll add it to the list of values to return. This reassignment will fix the issues we had. We can continue to use properties and methods with the same names across multiple composition functions. We'll know when there's an error because our editors will let us know when names clash. It's not like last time with mixins where everything was up in the air. In terms of reusability, the Composition API is far superior. This is one of the reasons why you may want to opt to use the Composition API over the Options API. It allows us to compose a component with little to no hassle. That wraps it up for the Composition API. It's a very powerful API for composing a component. I want to repeat myself again. The Composition API is not a replacement for the Options API. The primary purpose of the Composition API is to help with reusability. If you find yourself in a situation where you need to reuse logic, the Composition API may be what you're looking for. Otherwise, the Options API will suffice. We'll continue our discussion of the Composition API in the next lecture. In this lecture, we're going to look at how we can use the router with the Composition API. All official libraries released by the Vue dev team support the Composition API. If you decide to use the Composition API, you may need to use some of the methods and properties available by these libraries. We're going to start with the router. The router exposes information such as the route parameters or queries. We saw examples of how we might need these properties during the master project. The router comes with hooks for accessing its properties when we need them. In the resource section of this lecture, I provide a zip file you can download. Download it, unzip the files, install the dependencies, and start the server. Pause the video if you need to. Let's break down what's in the starter files. The project contains the basic configuration for the router and Vuex modules. If we look in the app component file, we'll find two links to the home and about page. Below them is the router view component to render the page content. Inside the views directory, we'll find the components for both pages. If you look at either components, they're rendering static heading messages. There's nothing special about them. Other than that, nothing special is happening with our project. Let's view the project in the browser. We'll find the links with the page content below them. We can switch between pages by clicking on the link. So far, so good. For this demonstration, let's attempt to make the About page more dynamic. Open the index file in the router directory. Let's update the About page to render information about a specific user. We'll start by updating the route for the About page. There are different ways we can make a route dynamic. The most common approach is to use route parameters. We'll add a route parameter at the end of the path. The name of the router parameter will be member. The route parameter we're creating will contain the name of the member. Let's open the About component file. We can access the route parameters through the $route object. This object is available in the template. We'll update the heading message to output the params.member parameter. Next, we'll go back to the app component file. We're going to update the link to the About page. We'll update the link to point to a non-existent member called admin. If we did everything right, we should be able to view the name of the member on the page. Let's open the About page in the browser to find out. As expected, the name is rendered on the page. The way we write templates doesn't change with the Composition API. The information about a route is accessible via the $route object. However, what if we wanted to access the route information in the setup function? This is where changes slightly differ. Let's go back to the About component file. We'll add the script block to the component file. In the exported object, we'll define the setup function. In some cases, we may need to access the router parameter in this function, or we may need the query parameters if they exist. We don't have access to the $router object because it's exposed via the this keyword. If we want access to the route information, we'll need to use hooks. Previously, we learned how to create custom hooks with the Composition API. Hooks are functions that export properties and methods that we can merge with our component's setup function. The router library comes with its own set of hook functions we can call to merge with our component. At the top of the script block, we'll add an import statement for the View Router module. The composable function we'll want to import is called useRoute. Notice how the name of the function starts with the word use. It's common practice to add the word use to hook functions to help indicate that this function is a hook. It's meant to be called within a component's setup function to merge additional functions and properties. The router library exposes its methods and properties through hooks. The hook we're importing will let us access the route object. In our setup function, we'll declare a variable called route. Its value will be the useRoute function. The route object will have the same properties you would normally find on the $route object. For example, let's say we want to use the member route parameter. Below this function, we'll log the route.params.member property. Let's refresh the page in the browser with the console opened. In the console, the name of the member gets logged. Perfect. Hooks are probably the most common feature you'll find yourself using with the Composition API. Most libraries will provide their own hooks we can use to extend our components. Let's explore another hook by the router library. The useRoute hook will expose information about the route. Other times, we may need to interact with the router, such as changing the current route. We'll need to use a different hook. Back in the editor, let's update the import statement for the View Router package. We'll import a hook function called useRouter. The useRouter function will return an object we can use to interact with the router. It's the same as the $router object we worked with previously. In our setup function, we'll create a variable called router. Its value will be the useRouter function. For this demonstration, we'll add a hash to the router. Below the log, we'll call the router.push function. We'll pass in an object. The object will have one property called hash. Its value will be #test. The push function, as we've learned, will update the router, primarily used to redirect the visitor to a different route. In this instance, we're adding a hash to the current route. Let's refresh the browser to view the changes. In the address bar, we can see that the hash has been added. The router library has exposed two hooks if we ever need information about the current route or interact with the router. It's important to know this stuff because it's likely that you won't be using View alone. You may need to work with the router. That's the basics of working with the router with the Composition API. We'll leave it at that. In the next one, we'll continue with the Composition API. In this lecture, we're going to use Pinia hooks from within our components. Believe it or not, Pinia has vast support for the Composition API. Most examples from the documentation will utilize the Composition API over the Options API. It's incredibly easy to use the state, getters, and actions from within a store. To get started, let's review the configuration for the store in our project. Inside the stores directory, open the counter.js file. Inside the store, we have a state property, getter function, and action function. The goal of this lecture is to use the state, getter, and action function from within the about component. We do not have to register Pinia with the application. I've taken care of that step for you. Open the about component. At the top of the script block, we can import the store like we usually would. Next, in the setup function, define a variable called store. Its value will be the useCounterStore function. Just like that, we have access to the store from within the component. It's that simple. The store exported by the file will be a function. We can call this function to gain access to the state properties, getters, and actions from within the store. Let's try using these values. At the end of the function, return an object with the store variable. Next, inside the template, add a paragraph tag. Let's output the store.counter property. Add another paragraph element. This time, output the double count getter. Lastly, add a button with dummy text. On the button element, add the click event listener with the prevent modifier. If this event is triggered, we're going to run the increment action function. That's it. Let's try testing our work by refreshing the page in the browser. As you can see, the application is completely functional. We can press the button to run the increment action. As we do so, the state and getter properties are updated. Admittedly, using Pinia with the Composition API is easier than using it with the Options API. Previously, we had to map these values. With the Composition API, it was simple as calling a function and returning the store. You may prefer the Composition API over the Options API for this reason. In the next lecture, let's continue our discussion of the Composition API. In this lecture, we're going to learn how to verify if a variable is reactive. The Composition API is meant for very large components. Somewhere along the line, it's possible to run into errors. An error because a variable is no longer reactive. If we lose reactivity, our application may not behave as users may expect. Vue provides two functions for verifying if a variable is reactive. They can be useful in debugging an application. Let's look at both of them. Currently, I'm in the first project we were working with when learning about the Composition API. Specifically, I have the numbers.js file opened. The Vue package has two functions called isRef and isReactive. Let's include both of them with the import statement. The isRef function can be used for checking if a variable is reactive that was created with the ref function, whereas the isReactive function will check if a variable is reactive that was created with the reactive function. We're going to update the import statement to include the reactive function because we'll need to create a variable with this function for demonstration purposes. Next, in the setup function, we'll quickly create an object called accounts. This object will be created with the reactive function we imported. It'll have two properties called checking and savings with random values. The reason we're creating this object is because we want to be able to test the isReactive function. Our numbers hook function didn't have any reactive variables. After creating the accounts variable, we'll perform a log to the console. The log will output the return value by the isRef function. We'll pass in the num variable to the isRef function. We'll create another log, but this time we'll log the return value by the isReactive function with the accounts variable. Both logs should output true since both variables are reactive. We didn't change them, so they shouldn't have lost their reactivity. Let's refresh the page in the browser with the console opened. Both functions are returning true. This means our variables are reactive. Vue provides both functions for testing if our code is reactive. It's useful for debugging an application. If you were to override a reactive variable completely, you will lose that reactivity. That may happen since we're not using the Options API, where we may accidentally lose reactivity. Other than that, these two functions don't have much use. That wraps it up for these two functions. I'll see you in the next one. In this lecture, we're going to finish our discussion of the Composition API by looking at a syntactic feature. By compiling our project with Vite, we have access to a special attribute to simplify the Composition API. Let's open the app component file. On the script block, add an attribute called setup. By adding this attribute, code written inside the script block will be wrapped by the setup function. That means we don't have to export an object, nor do we need to add the setup function. We can safely remove the export statement. Do not remove the inner contents of the object. Next, remove the name, components, and setup properties. However, do not remove the inner contents of the setup function. You may need to format your code. After doing so, remove the return statement. Voila! We're finished. We do not need to return values. Vue will automatically export the variables and functions defined from the block. Our template will continue to have access to everything. What about the components and import statements? If we import a component, it'll automatically be registered with the current component. For example, the app alert component will remain functional from within the template. As for the import statements, they'll be moved outside of the setup function. Behind the scenes, Vue handles the complexities. This feature simplifies the Composition API further. However, there is one problem. In the template, we're using an expression to output the name. However, this property does not exist in the script block. It does exist with the user object. In an earlier lecture, we converted the reactive object into separate refs. To fix this issue, we must explicitly define a variable. At the bottom of the block, call the toRefs function with the user object. Destructure the return value for the name property. By explicitly defining the variable, it'll be returned by the function. The name property will be accessible from within the template. Let's try testing our code by refreshing the page. Great! Our component is entirely functional. We can perform the same actions as before. For example, we can type in the input or press the buttons. Everything works. That wraps up our discussion of the Composition API. I hope you enjoyed it. In the next section, let's explore some more features of Vue.